Hey everybody, Jeff Oriema here. Welcome to Schema Workshop, where we design an API around a set of realistic requirements and constraints, trying something new each time. All right, let's take a look and jump right into the requirements. Order fulfillment status. So here's the context. A customer places one order. Items in that order may ship separately, arrive at different times, go on back order, or be refunded individually. Some products are digital and are never shipped at all. So we got sort of an e-commerce type setup here, maybe retail. All right, let's go on. The ask. Give a client enough information to answer what is happening with everything I ordered. For a given order, a client must be able to determine per item, what was ordered, product and quantity, how each unit is being fulfilled, a physical shipment or a digital delivery, the current status of each fulfillment, estimated delivery date and tracking info when applicable, a download link when applicable, and the constraints. A single order item's quantity may be split across more than one shipment. That's interesting. A single shipment may contain items from more than one order item. And digital products are never shipped. Okay, fair enough. These are pretty realistic requirements in that they reflect some of the caveats that we all have to deal with every day, but it's simple enough that I think we can get pretty far and show some of the principles of good schema design. So with these requirements in mind, note that they're phrased from the point of view of a user, and I do think that's really important. Our guiding light is the user, right? Even in GraphQL, for example, the spec even points out that the principles at play there are unabashedly and proudly client-centric, user-centric. If we move over to another tab here, I've scaffolded two files. On the right-hand side is a schema. This is where we will outline the design of our API and all the types and objects that will go into it, our domain objects. But on the left is the part that we're going to start with, which is a concept that some of you may have heard of. It's called a dream query. A dream query is how we model the ideal response type that we want to render the type of experience that we're trying to create for our user. Now, in this case, if we go back over to the requirements, we see the ask is to give a client enough information to answer what is happening with everything I ordered. And then all the requirements are there. So in that case, we're going to try to fashion a query that reflects those requirements, right? And you can imagine in your head how that user interface or maybe agent interaction might look or feel. So here we have an order status. Let's sketch out maybe an initial skeleton of the kind of information that we would want. So we want to say get an order. Let's just make that a field. And of course, because we're wanting to get information about a given order, we're going to accept that order ID as an argument, and you can see it's parameterized here as a variable. And let's go ahead and we would want the order number there, probably distinct from an ID. I've seen some retail services and the idea of an ID field might be an internal database abstraction, but an order number might be an external thing. So let's make sure that the number's in there, some sort of status indicator, right? And orders, we decided had items in it. So items, probably we want to show the quantity. That could be computed property maybe, we'll figure that out later. Each item probably have a reference to some sort of product entity. Let's come back to that. Let's go back to the requirements here. So delivery, tracking, download link, order fulfillment, I think is used here. So let's call this a fulfillments for now. Fulfillments, I can spell, excellent. And we would want for each, this would be a list field, I would imagine. And for each one, we'd want like a status quantity, maybe? We would want to know how many things are being delivered. And then there was shipping and digital delivery. So we would want, let's focus on shipping, estimated delivery and tracking information. Usually tracking, we wouldn't want to track, it would probably be a URL to an external service. Okay. And then back to the product. Let's just give it a name for right now. Maybe we add more later, but let's commit that. So let's say this is our dream query to start with. We want to get an order status, and from that query, we want all of this information here. Right? Dream queries can evolve over time, but again, we were thinking about this from the point of view of the user first. So it makes sense to start with the kinds of queries that are going to be coming from the user's device or the user's agent. If we're designing the API that returns this, I'm going to be using GraphQL because it's a pretty elegant way to represent domain objects. So let's go ahead and start with, in the query, we are going to go ahead and be able to accept that order with an ID. It's already there, right? And that specifies a type order. So let's go ahead and start there maybe. Each order will have an ID. Note that we're not necessarily going to need to return all of these fields in our dream query, but it's good hygiene to make sure that every field has an identifier that's unique. And I imagine we would have that for our orders. The order number will be, we'll call it a string. And note that I'm so far making all of these fields non-nullable. They seem like must-haves, right? If these don't exist, we got a big problem and it's a showstopper. We're asking for a status field. And I imagine that will be an enum. So let's just say status is an enum. And let's go ahead and maybe specify that here. And I'll just put some pending, processing, complete, and canceled, I think is probably one what we would do. Probably add like refunded too, but let's just keep it simple. And again, that can't be blank, right? So again, non-nullable. We have here items and fulfillments. So we would need to reference at least items, order item. And because it's a list, we would need to surround that with curly braces. And I don't see how you could do an order without an item. So let's make that nullable. Let's make the order item non-nullable, right? It would make sense to have a null item in this set. Let's do the same thing with a fulfillment. Now, these types are not actually defined yet, so let's go one at a time. Type order item, type fulfillment. Great. So these are stubbed out. And let's look at our dream query now. We filled out the order field, and now we have to get into the items bit. And then we'll get to fulfillments in a moment. So an order item will have a quantity. We'll call that an integer for now. And it can't not have a quantity, right? Even 0. So we'll just make that nullable. It needs to have a product. An order item without a product feels not reachable. So again, non-nullable. Let's stub that out for later. And let's see. Oh, and I put this in the wrong spot. The order item contains a reference to fulfillments. I messed up the nesting here. There we go. Because it wouldn't make sense to have fulfillments on the order. It would have to be per item. Now let's take a look at let's go with product first. We're only asking for the name. I'm sure we'll have an ID though. A product should have a unique identifier, and the product name probably be like a non-nullable string. Now you can imagine a product having probably dozens of fields in a real production deployment, but again, we're designing an API for the sake of getting together these principles, not necessarily for doing the most complete job in the world. So let's take a look at this fulfillment bit, and we're asking for quantity, which again will be an integer. We're asking for status, and this feels like an enum, so we'll give it a fulfillment status field. And let's go ahead and put that here too, fulfillment status. And fulfillment's more like a delivery type of thing, like a shipping type of thing. So let's just call it pending, in transit, delivered, and canceled. Similar, but not the same as our order status. Estimated delivery, give that a date. Now, I think this is the first nullable member that we should put in our schema. Estimated delivery is probably out of our control. Maybe there aren't estimated, there could be a null estimated delivery. Let's say, like for example, when I get things shipped, sometimes it hasn't reached the carrier yet, so they're not able to provide a date, so that feels fine. And then a tracking URL, same thing. And maybe something is on the way to fulfillment. It's in like a pending state, but there might not be tracking information ready yet, and that'll be a URL scalar type. So our first nullable fields here. In general, I know like GraphQL is designed to be nullable by default, and from a certain point of view that makes sense, right? Because it's much easier to make a nullable field non-nullable than to make a non-nullable field nullable. Annotating fields as non-nullable handcuffs you a bit more, but in this case, I think it's a very principled decision. I would encourage folks, as you're designing your API schemas, to really be very judicious about what's actually nullable. The rest of the time, consider non-null as your sort of default choice, and make yourself justify and make your team justify nullable rather than making them justify non-nullable. Okay, let's take a look here. We have an order, number status, which is good. We have our items bit of the order, that list. And in the order, it's being represented as a list. And each of those items is quantity, product with its name, which we've specified, and a fulfillment with quantity, status, estimated delivery, and tracking URL. All of these things seem to be captured here. Actually, one more thing here. We did not account for digital delivery. So digital delivery, I would imagine, would have something like a download URL, something like an e-gift card or something like that. So download URL we'll add here, and we'll make that a URL type. Again, non-nullable, because we aren't guaranteeing that any fulfillment object will have a digital delivery in there, so it needs to be nullable. Okay, now I think our dream query and the corresponding schema have reached a good first state, but I see an opportunity for improvement here. So good schema design is descriptive, right? And wherever possible, making things explicit, concrete, declarative, rather than implicit is where you want to be. So what we have here, particularly in the fulfillments object, is we have this estimated delivery, tracking URL, and download URL. All of these items are nullable, right? Because there are things that might not exist, but also there are some members that are mutually exclusive, right? If you're getting something shipped to you, you will not have a download URL. And if you're getting something to be downloaded, you won't have an estimated delivery or tracking URL. Definitely not a tracking URL, maybe estimated delivery in the case of there are some times when an e-gift card has a cooldown period or something for fraud prevention. So maybe you could use that, but regardless, there's definitely some exclusive logic here. So this is fine as is. I would put it in the quote good enough category, but I think we can make this better. So quantity and status, I think, are items we want to keep, but for each fulfillment entity here, each fulfillment object, I think we'll keep quantity as this, but I'd like to introduce sort of an intermediate object. So the client really can ask for and be specific about what kind of data it expects and under what circumstances it will get that data. So I think status is valid no matter what, although that would be an interesting bit to revisit later. But here we're going to use some polymorphism. objects are instantiated. And likewise, in this digital delivery download URL, again, because there's a cooldown period, maybe a download URL could be null, and that could be an expected condition. So let's leave these nullable for right now. But you can see here how this is a little more expressive, right? This schema is now able to be much more illustrative of our data model. And that benefits everybody. It benefits the agents making changes on your system. It benefits the clients. It benefits type safety. You can get more granular. And you can even see that here in all the different entry points. And I'm noticing a syntax error. I forgot to close the brace. Okay, great. Cool. And then one more update we need to make is we, a few minutes ago, changed fulfillment to fulfillment item, and we needed to update that reference here so that we can access that from order item. Now let's take a look at our API design at a high level. I'm using the schema visualization feature of Paul's Sandbox. So you can see here we have our order type that we're able to access from the root query. In this order type, you can access all those different items that you ordered. Each of them has fulfillment status and product information that we can drill into. And here's where the interrelationships start to get a bit more complex, right? You can see this fulfillment interface with all of its subtypes, dotted line related. This is one of my favorite parts of modeling an API with a technology like GraphQL. Visualizing all of these relationships becomes much more concrete, and it allows you to see design details in a higher level. Okay, so we're back in the editor. Let's take a look at our order field. Instead of entering by items, we want to give the opportunity for clients to go by fulfillments instead. Each of our fulfillments could have a status. So let's take a look at the schema here. What should this track to? So this would track to the fulfillment item, right? Which contains a status and items. So we can go ahead and look at each item from a fulfillment point of view. So each of these items should have their quantity, obviously. And remember, each of these are when we look at a fulfillment, right? These items are fulfillment items. So we have a quantity, and we'll say we want to get the order item. And because we're already coming at this from a fulfillment, we don't need that data, obviously, that circular reference. So then with that, we'll just put our product in our name. Should look familiar at this point. A lot of this will be shaped similarly. And then in here, we want our shipment data, right? Because these are already fulfillment iterations, all we need to do is put in because fulfillment is an interface, all we have to do is go ahead and fill in that on shipment. And you know what, I'll just go ahead and copy this from below. Sorry, I'm the world's worst Vim user, so my copy paste game is just not quite as fast as I've seen others. And we should only have to make them one change to our schema, which is on the order object. We need to be able to get fulfillments on that. And that should be a list of fulfillment, a non-null list with non-null members. If I could spell fulfillment. All right, there you go. So that should be everything. And now when I paste that dream query in here, I've just mocked up a quick server with some dummy data. And now we have a means of giving the client all that they're asking for. And we can enter this anyway, right? I'm doing the full dream query, but let's say we just want to go item by item. Well, there you go. We have a nice terse API response that's descriptive, that lets us get all the information we need in order to render the user experience or agent experience that we need. So that's it. Schema Workshop is a new format, so let me know what you think in the comments. If you have any suggestions for future Schema Workshops, I'd love to hear them. See you next time.